Hey guys, in this video we're going to be taking a peek at column vectors. So for foundation minions, this is pretty much all you need to know about vectors. Higher minions, this is really the beginning of our adventures in Vectorland. So in this video we're going to have a look at what column vectors are, what happens if we multiply them by a scalar, and how we can add and subtract vectors to and from each other as well. So let's get cracking. So first of all then, what is a column vector? Well, they're nothing really that scary, to be fair. They probably look a lot worse than they are. A vector is a pair of instructions telling us how to get from one point to another point. So a column vector in 2D always looks like this. We've got two numbers. We've got a top number and a bottom number. Now our top number is our x vector, and our bottom number is our y vector. So if our x vector is positive, if it's a positive number, then it takes us off to the right. If it's negative, then it takes us off to the left. And very similarly with our y vector, if our y vector is positive, it moves us up. If our y vector is negative, it moves us down. So let's have a look at drawing some examples of vectors. So here we have the vector then, a equals 2, 3. Now we've already got it drawn here on the grid. Why is that our vector? Well, the vector 2, 3 is telling us from any point to go 2 to the right, because our x vector is positive, positive 2, and then 3 up, like that. So you also might notice here that we've got an arrow on our vector. It's very important to put that arrow on. It tells us which way we're going. If we had the arrow pointing the other way, then it would be a slightly different vector. And it's always a good idea to label them as well. So it's important also to realise I could have put this vector at any point on this grid. There's no specific starting point. It's just telling us how we get from our start point to our end point. We go 2 places to the right, 3 places up. Cool. Let's look at another one. Okay, so vector B is equal to 4 minus 3. So again, we've got him drawn. Why is this our vector? Well, we've got a positive x vector of 4. So we're going 4 places to the right. But then we've got a negative y vector, which is negative 3. So then we're going down by 3 places. So we're going across by 4 and down by 3. So the vector is this chap drawn. Again, we've got the arrow on it, telling us which way along that line we're going. And we've labelled it vector B. Cool. Okay, the third one. So here, vector C equals minus 1, 2. Again, we've got it drawn. So from our starting point, this vector is telling us to go 1 place to the left, because we've got an x vector of minus 1. But then 2 places up, because we've got a vector of positive 2 for our y. So again, we've put the arrow on. This time we're going up and to the left. And we've labelled it C. Cool. Okay, one more. Okay, so vector D here is minus 2, minus 2. Again, we've got it drawn. So from our starting point, we have gone 2 places to the left, because our x vector is minus 2. And then 2 places down, because our y vector is minus 2. So again, we put the arrow on. We're going down and to the left this time. Jobs are good in. Okay, so that's how we can represent vectors on grids. Now we're going to take a look at what happens if we multiply them by what's called a scalar, or a scalar quantity. So we can't actually multiply vectors together, not in any normal way that we need to worry about with GCSE anyway. We cannot multiply vectors together, but we can multiply them by, again, what's called a scalar product. So if we multiply a vector by a scalar, then what we are doing, we are affecting the length of the vector. So for example, if we were to multiply a vector by 2, we're doubling both of its vectors, both parts of its vector, so the length of the vector itself would double. If we multiply a vector by 1/2, then we are halving the length of the vector. So let's have a look at some of these here then. So we've got the vector A equals 2, 4. So we want to find 3A. Well, we just multiply 2 and 4 by 3. So 2 times 3 on a good day would give us 6. And 3 times 4 would give us 12. So the vector 3A is 6, 12. What about the vector 10A? Well, for 10A, we're multiplying 2 by 10, which will give us 20, and 4 by 10, which would give us 40. So the vector 10A is 20, 40. What about minus A? So what we're doing here, we're multiplying our vector by minus 1. So minus A is just going to be minus 2 minus 4. So if you have a negative of a vector, that means that you go the opposite way along it. So the vector A equals 2, 4 would tell us to go 2 places to the right and then 4 places up. The vector minus A, which is minus 2 minus 4, tells us to go 2 places to the left and then 4 places down. So it would get us back to our starting point because we're going backwards along the vector. What about minus 4A? Well, then we're just multiplying each of the parts of the vector by minus 4. So minus 4 times 2 is minus 8. Minus 4 times minus 4 is minus 16. Jobs are good in. And then we've also got 1/2 A. So we're just halving both parts of our vector. So half of 2 is 1 and half of 4 is 2. So that's what happens when we're multiplying our vectors by a scalar. We just multiply each part of the vector by the number on the outside. Okay, now we're going to take a peek at adding and subtracting vectors. And there's really good news because it's really quite simple. So, to add two vectors together, you simply add the corresponding parts together. So you add the two x parts together and you add the two y parts together. If you're subtracting, then, well, we'll see as we go. So vector A plus B is going to be 2 plus 3, which is 5. And then the y part is going to be 4 plus minus 5, which gives us minus 1. So the vector A plus B is 5 minus 1. What about the vector A minus B? Well, that's going to be 2 minus 3, which will give us minus 1. And then 4 minus 5. So we've got a double negative there. That's going to be 4 plus 5. So that's going to be a positive 9. Cracking. And then one more example here. B minus A. So this time then we're doing 3. Take away 2, which is 1. And then minus 5 minus 4, which will give us minus 9. So that's how we add and subtract vectors. Now we're going to have a look at a couple examples where we're playing with scalars and additional subtraction. Okay, so then here we've got the vector A equals minus 3, 7, and B equals 6, minus 2. So for the first question, we want to do 2A add 3B. So let's first of all work out 2A and 3B separately. So 2A is going to be 2 times minus 3 is minus 6. 2 times 7 is 14. So 2A is minus 6, 14. 3B, well, 3B is going to be 3 times 6, 18. And then 3 times minus 2, minus 6. So now we know 2A and 3B, we can just add them together. So 2A add 3B, then we've got minus 6 add 18, So that will give us 12. And we've got 14 add minus 6. 14 minus 6 is going to give us 8. So the vector 2a add 3b is 12, 8. Jobs are good in. Okay, now we want to do 5a minus 2b, so let's do it the same way. Let's find 5a. So 5 times minus 3 is minus 15. 5 times 7 is 35. So 5a is minus 15, 35. And then we want to find 2b. So 2b is going to be 2 times 6 is 12. 2 times minus 2 is minus 4. Okay, so now we need to do 5a minus 2b. So minus 15 minus 12 is going to give us minus 27. And finally, 35 minus 4, double negative again, 35 plus 4 then is going to give us 39. Okay guys, that's column vectors. Hope you found it useful. Was this video helpful? If so, don't forget to hit the thumbs up button and leave me a comment letting me know how you get on. Also, don't forget to subscribe to the channel so you never miss any videos. For any further information, you can find me on Facebook or Twitter. Search for Maths with Melv. Cheers guys.